Okay, in this video we are going to do a line integral that is with respect to x instead of with respect to arc length. So we can tell it's a line integral because of the little c here. So it's the notation that tells us that. So these are kind of just substitution problems. So if you just go ahead and do what it tells you to do, you'll be fine. So we have the integral. The bounds are actually given. So it's the line integral of 2xy dx. Our curve c, or our path, is x equals cosine of t, y equals sine of t, so it's kind of a circle, a unit circle, and then t goes from 0 to pi over 2, so it's actually the first quadrant of the unit circle. So our bounds are 0 to pi over 2, so right there, let's fill those in, and then we want to replace our f, right, our scalar function, which is 2xy, so the 2 is there. X is given as cosine of t, so let's replace that. Y is given as sine of t, so let's replace that. And then we also need to substitute for dx. Since x is cosine of t, dx will be negative sine of t dt. And now it's a single variable integral, all with respect to t, so you just go ahead and kind of do it. So I'm going to pull out the negative 2 and rewrite the integrand as sine squared and then cosine and then dt. So this is actually, you can reverse the power rule on this. If you let u equal sine of t, du is cosine of t dt. So we're going to end up with negative 2 and then 1/3 sine cubed of t. And then our bounds are 0 to pi over 2. So now you got to think about it. The sine of pi over 2 is 1, and the sine of 0 is 0. So sine of pi over 2 is 1, sine of 0 is 0, so when we substitute in, we just get negative 2, and then times 1/3. And so our final answer is negative 2/3. So that's a really quick example of a line integral that is just with respect to x. Honestly, these don't come up that often with scalar functions. They come up all the time with vector fields, which I think is maybe why they're in textbooks. I'm not really sure. All I ever see is them as examples. So I hope you found this helpful, and good luck.